Now we will continue with the different startups. We have 5 startups under the same dynamic, 10 minutes for each representative of the startups that have been created under MIT. Let's start with the first one. Welcome to the scenario, Brendan Smith, representative of SiTration.
Today we have 15 full-time team members and growing all the time, hiring more great people to bring on the team. What we think about primarily at SiTration, as you can see here in our title, is developing a new process for what we call the ultra-efficient extraction and recovery of copper and other precious metals and minerals, largely in the mining sector, looking at primary mining streams like leachates, but also from mining waste streams like tailings and acid mine drainage. So we'll talk a bit more about this in the next 10 minutes. And so really importantly, the reason why we're doing this at SiTration is we feel so strongly that the global energy transition is going to require a critical minerals and a critical metals revolution. And what do we mean by revolution? That can mean a lot of different things. To SiTration, it means we need to develop and implement new and innovative solutions for what we think of as full value mining. And that may have different definitions for different people. When we think about full value mining, we mean getting the full value, not just out of the primary ore that we're digging out of the ground, but also extracting and recovering the full value from the waste streams, the tailings, the acid mine drainage as well, while at the same time recycling chemicals and recycling water back into the mining process, so we don't have to just throw that out into the waste and desalinate more water or pipe more water from the ocean, for example. And so copper is a great example of this. I think actually the most important global example with recent news, and it's great to be here in the heart of the copper producing nation of the world in Chile. What we see is, as I think all of you today know, is a steadily increasing demand for copper through 2050 and beyond. And copper is special because it's one of the most diversified commodity metals in that it's needed for not only the grid technology and expansion, but also energy generation and storage, of course, construction, and a whole plethora of other different industrial applications with which you're all very familiar. But in the face of this almost inevitably growing demand, I think we all agree that it's going to happen, and it is happening today, we have several challenges and what we think of as headwinds that we have to push through to be able to meet this demand, of course. And so we have, as we all know, declining ore quality that was mentioned this morning by Antofagasta's CEO. We know that over the last 40 years, we've seen about a 50% decline in copper ore grades, which is a pretty staggering decline, and one that's not going to slow down or reverse course as far as we know. We also know that we're losing a lot of value into the waste stream, as I mentioned before. So chiefly not really with copper, but a whole plethora of other critical minerals and metals that are also essential for the energy transition are largely flowing into the waste at maybe dilute concentrations that can't be economically or sustainably recovered so far today. And finally is the negative impact. And so we all know that mining has an impact. It's a very necessary impact to be able to achieve this progress that we need to achieve. But really importantly, as we try to get more resources out of the exact same amount of rocks that we're already mining today, but needing to be more productive and more efficient, we need to mitigate that waste production of solid and liquid waste and tailings, consumption of energy and water in that process as well. And so I think some of these headwinds are actually driving the opposite trend in what's predicted in mining production of copper, which is going the other way in a negative direction for all those reasons I just mentioned. And so we're seeing projections of a shortfall of 40 to 50% already by 2040. And so what are some of the key pieces that could actually help to close this gap as we really need to do? When we look at the market and the industry and the sector today, what we see is an incredibly complex process. And in a lot of cases, we're using hydrometallurgical and pyrometallurgical processes or methods that were developed in the 20th century up to 100 years ago. And of course, we have incremental innovation throughout that 100 years or century, but not necessarily a lot of new technologies or approaches because it's very difficult to do. And so these things are complex, 10 or 15 steps to get one critical metal target, for example. They're high cost, takes a lot of resources, energy, water, and chemical coming into the process and going out into the waste, not being reused. And of course, then harmful to the local and global environment. And as I mentioned before, leaving a lot of those more dilute, long-tail resources that are very high value and very critical for our future in the waste stream unrecovered. And so finally, this is where SiTration comes in. We're working to enable a paradigm shift in the mining sector and other adjacent sectors in metals and minerals by deploying a fully electrified solution with no chemical usage to extract these minerals, concentrate them, and recycle other resources in the process in a very streamlined way. At the core of this system is two chief technical pillars that SiTration has developed, scaled up, deployed, and patented. The first is a silicon-based filtration membrane. So many of you are familiar with filtration. The difference with our membrane is it's uniquely durable. And so we can utilize this with streams directly of pH 0, pH 1, very high TDS, very high solids loading, and pull out clean water or clean acid for recycling in the process. At the same time, we can also up-concentrate by, say, a factor of 10 to 15 times those dilute, highly valuable things like rare earth elements or precious metals in that tailings water, for example. The second piece of technology we've developed and are deploying today is a silicon-based electro-extraction module. You can tell we really like silicon at SiTration. It's actually in our name, you probably noticed. And it's a silicon-based electro-extraction module. It gives us the same durability as the filtration membrane, but the application here is very different. It's very much similar to electrowinning that you're probably all quite familiar with, where we're pulling out things like copper, cobalt, nickel, and other precious metals like gold and silver in a single step with no chemical directly from those complex and challenging streams. And so when we talk to our global mining partners, including Antofagasta, who we're very thrilled to be working with today, about the advantages here, we see several really key important advantages. So the chemical-free nature of what we're doing, extremely important in terms of the operating costs, the sustainability. We can, as I mentioned, get to that really long tail of dilute, profitable byproducts that typically aren't really leveraged in most assets. And we can do this while really importantly reusing water and acids that are going to the process in terms of lixiviants. At the same time, it's a very modular, low capex, low opex system, and so we can scale up or down with on-site process requirements of a specific asset. And then really importantly, the durability speaks to this a little bit, but we're highly adaptable to very diverse lixiviants. So you can think about bioleaching or the chloride leach that we've been talking about at these sessions, and we're compatible with all those things in the exact same way we would deal with a sulfuric acid leach, for example. And so a few examples for you with more specificity and in a quantitative way. I mentioned we're dealing primarily with PLS or primary leachate, and also wastewater like tailings or acid mine drainage. And from either of these feed streams, in that single step with no chemicals, we're able to pull out 4/9 purity copper, which is extremely important, of course, as a standard for the industry. We can do this with a very flexible form factor, either with high purity copper powder, which you see here on the slide in that single step. We can also do a highly dense cathodic copper sheet like you would find in a standard electrowinning process, for example. Really importantly, energy consumption has to stay low. That drives the operating cost. And so we can achieve well below 3 kilowatt hours per kilogram of copper, which is approaching on par with commercial electrowinning today. The yield can also be very high, so we can achieve upwards of 97%, even approaching 99 or 99.9%, depending on the application. And as I mentioned, high compatibility with diverse lixiviants, including chlorides and, of course, sulfuric acid as well. And so we're not just stopping at copper. It is our number one focus, of course, unsurprisingly to all those in the room, but with the exact same hardware, the exact same process, we can actually pull out diverse critical metals and minerals from very harsh conditions. So think about hydrochloric acid streams with pH -1. We can directly pull out gold that looks like this from a stream like that. Also addressing platinum group metals, platinum, palladium, precious metals like silver. I mentioned the base metals, and other really critical minerals like lithium, manganese, and iridium, to name a few others that we're doing with partners today. So I want to really emphasize that we're not just a streamlined copper producer with high efficiency, but also really importantly unlocking this multi-metallic value of an asset, both in the primary process and the waste stream as well. So where we are today, we're still relatively early, but we're scaling up quickly. We took our demonstration or a picture of this to Sentinel yesterday, and I think some people found it kind of funny because it's so small. But we are really importantly looking to scale up very quickly with partners around the world. So today we're deploying a 1,000 liter per day system on a site with Rio Tinto in the United States, primarily to pull out copper from a waste stream being acid mine drainage. So that's being deployed this summer, and we're looking to bring something similar very soon to Chile as well. But importantly, the scale-up potential is very high. So we expect to do a 10x scale-up to 100,000 liters per day by the second half of 2026, and then going up much more quickly from there. And so one of these great partners today is, of course, Antofagasta. We are down here to discuss potential next steps with you as well. And we're looking at different applications in raffinate, PLS, and possibly on the waste side. And then Rio Tinto, I mentioned, we're pulling out copper from that acid mine drainage stream today on a site in the United States. So I just want to close by saying we're extremely excited about Chile. We're really appreciative of Antofagasta inviting us down here. We're very excited for the next steps and to continue working together and scaling up the technology and process. The reason we're so excited about Chile is not just because it's the copper capital of the world in terms of proven reserves, of course, which it is. It's more about the attitude of doing this, doing the scale up, while also generating all the clean energy production that you're generating, and these state-of-the-art water management systems that we feel overlap completely with SiTration's mission. So not only are we also trying to be very energy efficient, very much streamline the copper extraction process, but we're also looking at reusing the water and chemical on site to really advance the sustainability aspect of what we're doing and what our mining partners are doing. So with that, I'll finish up. Looks like right on time. I would love to contact all of you in the future if you have interest in learning more. You can find my email down on the bottom of the slide there. And I really appreciate your time and attention. Thank you.